You can look out at a clear sky or still lake and think everything is pristine. But our biology evolved to detect immediate, physical dangers, not the microscopic, accumulating threats of modern industry. Every day, industrial processes release byproducts like volatile organic compounds and PM2.5. These particles are small enough to pass through natural biological filters and enter the bloodstream, yet they remain completely invisible to the naked eye. Because these elements are imperceptible, they silently build up in the air we breathe and the soil we cultivate. Over years, this accumulation is what leads to respiratory crises and the slow decline of local ecosystems. Without accurate measurement, there is no accountability. We cannot regulate the unquantified or enforce estimated safety standards. Safeguarding our health in an industrial world requires constant, high-resolution data. We need tools that can map the atmosphere with the same clarity we use to navigate the streets of a city. The first layer of this data network sits at the source. Continuous Emissions Monitoring, or CEM systems, are the high-tech observers integrated directly into the smokestacks of power plants and refineries. This schematic shows the process in action. A gas sampling probe in the vertical stack captures raw exhaust. Sensors extract data on temperature, pressure, and flow rate, converting this information into electronic signals routed to a control room for immediate analysis. This continuous loop provides a live, verified readout of exact pollutant concentrations. It eliminates the guesswork that used to define industrial reporting. Moving beyond the factory fence, ambient air quality monitors take over the watch. These stations are positioned in residential areas, capable of detecting pollutants down to a single part per billion. These units use interchangeable sensor cartridges, allowing a single station to track multiple gases simultaneously, while also recording environmental factors like wind speed and noise levels. Together, these systems act as a translation layer. They take abstract atmospheric threats and turn them into hard, actionable numbers that anyone can understand. This level of scrutiny isn't just for the sky. Protecting a community requires the same constant observation of the water we drink and the soil that grows our food. Water monitoring systems track 3 distinct categories of data: physical attributes like turbidity, chemical markers like pH and heavy metals, and biological threats like bacteria or viruses. At the same time, soil monitoring prevents agricultural lands from becoming contaminated, ensuring that industrial runoff doesn't compromise deep groundwater reserves. The success of these systems relies on near-reference data. This is a standard of measurement so precise that it can be traced directly back to international environmental protocols. This chart shows the difference continuity makes. Manual, intermittent testing relies on isolated data points that can miss sudden events. A continuous monitoring system draws a solid line, capturing every spike as it happens. To meet the requirements of modern regulatory agencies, these sensors must be factory calibrated and run 24 hours a day without interruption. When data collection is this consistent, we can build accurate models of environmental health and identify potential risks long before they turn into disasters. When every gram of exhaust is logged the moment it leaves the stack, the dynamic of industrial oversight changes. Real-time transparency makes it much harder for a facility to ignore its actual impact on the local environment. This unbroken stream of data gives governments the evidence they need to enforce local laws and international standards with scientific certainty. We move from a reactive strategy to a proactive one. By detecting a pollutant spike early, operators can fix a malfunctioning process before it escalates into a public health threat. This approach does more than just avoid fines. It protects the immediate health of families and keeps local ecosystems from reaching a tipping point. The visibility provided by these sensors creates a path where industrial progress and environmental health are no longer mutually exclusive. It is the evidence-based foundation for a sustainable future.